All right, here's the grand finale extra credit for the year. Let's make sure you get these concepts all cleared up for the test. Number 1, tell whether this relationship is an inverse variation and explain. Well, remember, for an inverse variation, when you multiply the x and y, you should get a constant number k. So all you have to do here is check. X times y in this situation is negative 24. X times y in this one is 6. X times y in this one is negative 24. So they're not all the same. So it would be no. The xy needs to be a constant value. All right. Next one. Write the equation of the inverse variation graph below. Well, an inverse formula, remember, is y equals k over x. And remember, that's how they get the xy up here. xy equals k. Because if you multiply both sides by x, you get xy equals k. So if we just have k, then we're all done. So we're going to do the exact same thing we did up here. We need to get xy coordinates and see what our k value is and plug it in. So if I take this value, it's negative 1, 3. So xy equals k. Negative 1 times 3 equals negative 3. Y equals k. I'm sorry, that is not true. I just found out what k was, didn't I? Let's get rid of that. I love these things. Gone. Y equals k, which is a negative 3 over x. And you might say, well, what if I picked a different number? Sure, go ahead. This is negative 3, 1. You still get negative 3 when you multiply them. This is 3, negative 1. You still get negative 3 when you multiply them. This is 1, negative 3. You still get negative 3 when you multiply them. So it doesn't matter what point you pick, because it's an inverse variation. So it will always equal the same constant. All right, now, down here on these problems, on a balanced lever, weight varies inversely. So it tells you that as the distance from the fulcrum to the weight. So the two things that vary are the weight and the distance. And what did we find out about those variables? When we multiply those variables, we get our constant k. Okay, so when I take and I multiply the weight and the distance from the fulcrum, I'm going to get k. So let's do that. What is 1.2 times 12.5? And the answer is 1.2 times 12.5 is 15. Okay, so that's our k for anything. So now it's saying, okay, but what happens over here then? So we have, again, you can use, you can use xy equals k, or you can use your, your formula, because now you know k is 15. So let's see, what do we have here? What do we put in for the x? X was the inches. So I'm going to put the 3.75 in for the x. And when I figure out y was the weight. So then when I figure out y, I'll have the weight, which is a. So 15 divided by 3.75, and we get 4. We look and see what the unit was, ounces. So the answer is 4 ounces. Now identify the asymptotes. Okay, remember, whatever makes the bottom here 0 is your x asymptote. So in this case, it's just 0. Now, if there was an equation on the bottom, let's say there was 5 over 2x plus 3 on the bottom. Slide that down. If we had something like that, well, then you would need to take this and set it equal to 0 and solve it. Subtract 3 from both sides and divide by 2. Then that would be your x asymptote. Okay? So whatever's in the bottom, you're setting equal to 0. Now the y asymptote is exactly what's right here. So in this case, it's a negative 10. If it was a plus 10, it would be a positive 10. It's exactly what's there. And that makes that nice, because then when you come to a problem like this and it says, I'm going to see if I can get that a little clearer, and it says which graph, well, figure out the asymptotes, because maybe more than one of these graphs have the same asymptotes, but from first glance at it, they don't. So the x asymptote is what? X plus 1 equals 0. Subtract 1, x is a negative 1. A lot of you can see that from looking at those. That's fine, but I don't want you to forget what we're really doing, which is setting this equal to 0. The y asymptote is negative 2. So remember, x is a vertical line, and y is the horizontal. So we need to look through a vertical line that is at negative 1. Okay. Well, here's one. First one I looked at is, okay, that's at negative 1. Is there any others? That isn't. That isn't. Oh, that is. So it's got to be one of these two, because they both have a vertical at negative 1. So let's look at the y. It's a negative 2. Okay. So at the line, horizontal through negative 2, that leads us with this one. That's going through at negative 2. This one's going through at positive 2. Find excluded values. Again, excluded values are when this bottom part is equal to 0. So in order to do that, you've got to figure out which values make this 0. And in order to do that, you have to factor first, because you can see there's a c in both. So you need to factor out a c, and then you're left with a c plus the 3. So remember, our zeros property tells us that when you have two things multiplied together, this and this whole thing, if one of them is 0, it will equal 0. So the excluded values would be when c is 0, or what would make this 0? A negative 3. Those are my excluded values. Okay, then we go on to simplify, and that's much of what the rest of the test is. So you need to be clear, concise, and careful. I look in the bottom, there's nothing more I can do. I look in the top, there's two terms. I cannot cross those off. If you were going to cross off 5x and 5x and get negative 10, it would be 100% incorrect. Okay? Why? Because of the subtraction sign. If these were multiplied, you could do that. Not when they're subtracted. Okay, so we need to factor, because when we factor, we get multiplication, because we are taking out a 5, and then this becomes a multiplication here. So if you divide this by 5, you get 2. Oh, I'm sorry, you don't get 2 anything, do you? Let's get rid of that. Oh, no, I screwed up. Shoot. Yeah, these guys don't always like me. Okay, if I divide a 5 out, I'm left with an x minus 10 divided by 5 is 2. So now I can either cross off the 5 with something down here, or the x minus 2 with something down here. There's no x minus 2 down here, but there is a 5. And since the 5 is multiplied by the x, I can cancel that as well. So what do we have left? We have x minus 2 over x. And again, can you cross these x's off? No. Same reason you can cross these 5x's off. You have it subtracted. When it's added or subtracted, these stay together. If you don't have an x minus 2, you can't cross anything off. Next, k plus 5. Nothing to factor out. But I see a trinomial on the bottom, so we're going to factor. What plus what equals 2? What times what equals negative 15? I'm going to guess it's 3 and 5. And it's got to be a negative, so I think it's going to work that way. So my answers are k plus 5 over k minus 3 and k plus 5. yay. I can't just cross off a k, and I can't just cross off a 5, but I can cross off that whole thing. What's left up here? It's not 0, 1. So I have 1 over k minus 3 in the bottom. Okay. Next page. Some of you I know probably just love these. I do, but it's kind of a personality because it's fun to just kind of break everything down and make it look simpler. All right, multiply and simplify your answer. My recommendation on these is you simplify the numbers and then put the variables together and simplify them second. Okay, so like this. I would look at this and remember I'm looking at the top and then I'm seeing if there's anything I can reduce. I can't reduce 4 and 20. They're on the same level. But there's a 5 up here because it's multiplied. I can divide this by 5 and get 1, divide this by 5 and get 4. So then my recommendation is you go across and put things together. So when you're multiplying across, you add the exponents. M squared plus m to the first is m to the third. N to the sixth times n to the second is n to the eighth. All over 4 times 4 is 16. N to the third, that's it. M to the third. Okay, and then simplify the letters, because otherwise what happens is this all gets all crisscrossed and we miss things. I've done it, so I know that happens. So I look at this and I see, ooh, m to the third, m to the third. Those entire things are gone now. And then I got an n to the eighth and an n to the third. So 3 of these will cross off with 3 of those, so I'm left with a 5 there. So I have n to the fifth over 16. All right, down here, remember, this is multiplying and this is over 1. So let's look in each part. There's 4 parts, top, bottom, and you look to simplify things. And when I say simplify, I mean factor. So 3 times x minus 2. That was how that one factors. This is a trinomial. What plus what equals 4? What times what equals negative 12? I'm going to guess it's a 2 and a 6. It's got to be negative. That has to be positive. So it's going to be that way. And so I'm left with x. And actually, I'm going to rewrite this so it doesn't get confusing for you. Excuse me. Anything in the top can cancel with anything in the bottom. Is there anything there? There is. Remember, these got to stay together. So I can only cross this and this off. So I'm left with 2x times x plus 6, keep your parentheses, over 3. And let's just get rid of all parentheses just to be simplified completely. So let's multiply that out. 2x squared plus 12x over 3. All right, next, we're dividing. So the only difference between this one and this one is we have to make sure we flip this. So before I flip it, though, I'm going to factor this because I see 2 terms, and I see a 4 that can be taken out and an n. So if you take out a 4 and an n, you're left with 1n plus 2. And then if I'm not sure that was right, I can multiply to make sure, and I go 4n squared 8n, yes. Okay, I did that right. So I'm going to rewrite that here. Times 2n plus 4. You can factor out a 2. And that goes now on the bottom because I'm changing it to multiplication. And I saved the bottom one here because that is a trinomial. So we need 2 numbers that equal negative 1. 2 numbers that multiply to give you negative 12. I'm going to guess it's 3 and 4. And it has to be a negative, and so does that. So that means the bigger one is going to be negative. And I'm left with n plus 3 and n minus 4. Anything on the top can now cancel with anything on the bottom. Do you see anything? I do. N plus 2 Anything else? Yep, there's an n minus 4. Anything else? Yes, there is. The 2 and the 4. Divide them each by 2. So what is left here? And this is where you have to be careful. We got a 2 and we got an n times this over nothing, 1. So again, we want to get rid of our parentheses for our final answer. And there you go. Now we switch to adding. So when we add, the denominators have to be the same. And they are right here. So I'm going to simply add all these together. But I'm not just going to rewrite them. While I'm doing this, I'm going to put them in descending order and put the comment-like terms together. So in other words, I see a power of 2 here. So that would be my first term. Plus, cross it off so I don't forget. A's would be next, and I got a positive 2a here and a positive 3a, and this is positive, so I have positive 5a. And then I have a 6 plus a negative 20, so that's a negative 14, all over the common denominator of x minus 2. Now, what plus what equals 5? And what times what equals negative 14? This is why I push factoring so hard, you guys can see. We do a lot of it. Okay, so 14, 2 and 7. And it's got to be negative, that has to be positive, so it's going to be the smaller one. And so it'll equal a minus 2 and a plus 7 all over a minus 2. And yes, you can put your own parentheses if you like to just see everything look exactly the same, that's fine. And we're left with a plus 7 for our final answer. Okay, now when we get to the least common multiples, remember we have to look at each and factor them down. So first thing I'm going to do is factor this first one down. It has 2 terms, and I can see you can take a p out of it, so p plus 8. That's that one. And I look over here and I see I can take an 8 out of here and have p plus 8. So I've got these two. And I got to make sure I include everything in there. But I don't have to include it if it's in there multiple times. I just have to take the highest power of it. So are there any other p's? You know, a p to the second, a p to the third, a p to the fourth? No. So p has to be in my answer. Are there any other p plus 8s? Yes, there's one here. Is it to a higher power? No, it's the same. Okay, so I only have to put it in there once. I just want to take the highest power. What else is left? We got an 8. So our answer then is going to be, I'm going to put the number up front. And we can just leave it written just like that. If you did multiply that out, I would not mark it wrong. Because that might be the easiest way to remember, just to always get rid of the parentheses. But for the least common multiply, I don't mind seeing it written like that. All right, so we need to subtract. Are the denominators the same? No, they are not. So hopefully, you guys are familiar enough with this stuff that you see x squared minus 4 and you say, yes, difference of 2 perfect squares. So that breaks down to x plus 2 and x minus 2. That is something I'm really hoping you see by now. And the bottom over here is only x plus 2. So I got that here, but I don't have this over here, do I? So to get a common denominator, I would only need to make sure I multiply this top and bottom by this. So I'm going to do that. I'm going to multiply this by x minus 2 and this by x minus 2. And then do you agree that this would be the same on both? Okay, so I don't have to change the top right now. I'm just going to leave it the way it is, 2x squared minus 16 over x plus 2, x minus 2, minus, and then I have the bottom here, x plus 2, x minus 2. And now I'm going to look at the top here. And I'm going to actually multiply these out because I'm going to have to combine them over here with these. So I'm going to leave this a minus here and not worry about that yet. but multiply these. So x squared minus 2x plus 4x minus 8. Okay, so when we look in here, are there any like terms up here? Yes, of course, these middle terms, right? So those together give me a positive 2x. So I'm just going to put that in there. It's a plus 2x, so I had a negative 2x and a positive 4x. So the reason, though, is let's put them together now, but remember, we're going to put them all together. The bottom is the common denominator. And the top, I'm going to rewrite that one. That doesn't change. But it is a little tricky because this is subtraction. So that has to get distributed through to each of the three terms. So it basically switches the sign of all three. So this is a positive here, and now it's going to be a minus x squared minus 2x plus 8. And we now combine like terms in the top. We got a 2x squared and a minus x squared. So that would be an x squared and a minus 2x minus 8 all over x plus 2x minus 2. It's a little bit of a longer one, isn't it? So we still have to look at that top piece. It's a trinomial. Can we break that down? Because maybe it'll cancel off. Maybe it won't, but we can try it out. So what plus what equals a negative 2, and what times what equals a negative 8? I think we got a 2 and a 4 going here, and I need it to be a negative, so the bigger one. Okay, so that is going to be x plus 2 and x minus 4 all over x plus 2, x minus 2. Oh, that works nice, doesn't it? These cancel, and this is your final answer. Back to the top here. Is there another page, or is it all in two? Yeah, there is a few extra. This was a long one. It is. It's a tough test. It's probably one of the tough ones of the year. So you guys need to make sure you're ready for this. Okay, so when we look at this, sometimes it's helpful when people, well, first of all, divide out a common factor. When you look at these, what's a common factor? A 3. That's right. So I'm going to take out a 3, and then I'll have a 4y to the 5th. Plus y to the 3rd, minus 6, and I'm going to divide it this way so you can see it. So because this is multiplied now, I can cancel that 3 out with the 6 and get a 2 there. So you can either leave it like this. I will accept it like this. Or sometimes what they've been doing with these problems is putting these together with each of them and separating them. So if you look, again, if you wrote it like this, that's fine. Or your answer could be, if you put this over this, what do you get? 2y to the 3rd. If you then plus, what's this? Y over 2 minus 3 over y squared. I'm going to leave that for those that would love a little extra challenge. If that was confusing to you, just write it in this form. But otherwise, some of you more advanced kiddos who really love the challenge of math, try to write it in that form. That's good practice. Number 16. Let's see. We got a trinomial on the top. Well, you know what that means, right? We got a factor. What plus what equals negative 13? What times what equals 40? 4 times 10. Nope, that's not going to work. 8 and 5. There we go. 8 and 5. 8 and 5. That's got to be positive. That's got to be negative. So they're all negative. So we end up with b minus 8 and b minus 5 all over b minus 8. Gone, gone. Nice. We're done. So some turn out super simple like that, and others, you got to put some work in, right? Okay, this is another one of those simple ones, and I hope you noticed there was 2 types of 16s, because I want to make sure you're able to do this, whether it's a trinomial that you have to do this method, or this. What's this again? I just dealt with that in the other problem. A difference of two perfect squares. So you need to know that that is broken down b plus 6 and b minus 6. All over b plus 6. Lovely. Done. That is a 6. Doesn't look like a 6, but it is. All right. Now, you will have one of these on the test where you need to do the long division. You can't do this in your head, people. You got to show me the work. Can't tell you how many people. Well, actually, it was more in my other school. Just magically did it in their head. Amazing. All right. So you put this on the outside. You're going to rewrite this and make sure everyone is filled in. So I got an n squared, and then I should have an n, and then I should have a number. So in this case, they all were there. I didn't have to fill any with a 0n. Now, you take the first value and the first value. You say, what do I multiply this by to get this? And when I get my answer, it's going to go above that second term. And the answer is, I need a 3 and I need an n, 3n. Multiply 3 times n, 3n times n is 3n squared. Now notice I go back to this one to put it under here. Then I multiply it by the second. 3n times a negative 2 is a negative 6n. Draw the line, and then what? Subtract. So both signs switch. That should cancel. Add those, you get 4n. Bring that down, minus 12. Again, back to this. What do you multiply the first term by to get the first term here? And that is a positive 4. 4 times n is 4n. 4 times negative 2 is a negative 8. Draw the line, switch the signs, and this should be gone. And this should be negative 4. So that means this is a negative 4 over n minus 2. Last one on this page. Now this is just a straight proportion because there's a fraction on each side and only one fraction on each side. When that's the case, you can just do your good old cross multiplying. You don't have to. You can do a different way too, but I'm getting a common denominator, but I'm setting the tops equal, but I think this is the easiest way. So x times x plus 3 equals 2 times 2x plus 1. So x squared plus 3x equals 4x plus 2. Want to get everything on the same side. Probably going to get a trinomial that we have to factor. So I'm going to subtract the 4x from both sides. I'm going to subtract the 2 from both sides. So I'm going to be left with an x squared minus x minus 2 equals 0. So I need two numbers that add to give me a negative 1, and two numbers that multiply to give me a negative 2. 1 and 2, both negative. So that does factor x plus 1, x minus 2 equals 0. Zero properties, the zero property states that if this equals 0, one of these two has to be 0. So either this one is equal to 0 or this one is equal to 0. And when you solve those, which a lot of you, again, you can do that in your head if you're able. Negative 1 and 2, those are your answers. All right, we're getting there. I know these are always the longest videos, but feel free to keep using them and studying. We got 2 more here to go. The first one now, how is that different than the other one? It's not just a fraction equals a fraction. If you had this, you could cross, you can cross multiply like we just did, but we get the 1. So we got to get the bottoms all the same on this. So look at the bottoms here. Got to get a common denominator in all of them, because then once the bottoms are all the same, we can set the tops equal. Because oh, I won't show you on this one. Let's just do this. So I've got a t minus 3. So if I multiply this side by a t minus 3, and I multiply, put that over 1, this by a t, and this by a t, I'm going to be left with 8 times t minus 3 over t times t minus 3 equals 22t over t times t minus 3 plus 1t over. Uh-oh, that's not right, is it? I don't get the same thing here. I got to multiply this one by t minus 3 as well. That's not the same common denominator. So I have t times t minus 3 on the top, all over t times t minus 3. Okay, so the bottoms are all the same. So you can now take all the tops and set that whole top part equal to it into one equation. Okay, it's kind of like if you had 3, 6 equal 4/8. Okay, you guys know those are equal. But let's just say we had to get a common denominator. If I had to get a common denominator, what would that be for 6 and 8? It'd be 24, wouldn't it? So I'd multiply that by 4 and that by 4. And what would I multiply that by to get 24? That by 3 and that by 3. So I get 24 on the bottom, and guess what happens on the top? The same as well. So we're kind of using that same mentality here. Once the bottoms are all the same, I can set the tops equal because they are equal. So let's get to work. Got to factor these, or multiply these out, so I get 8t minus 24 equals 22t plus, I got to multiply these, t squared minus 3t. So basically now we got to just kind of get everything all onto the same side. I see there's only one t squared, and it's here and it's positive, so I'm going to leave it there, and I'm going to move everything else over. So I'm going to move over. Well, actually, first I'm going to combine like terms here. Let's do that first so we don't get too confused. Because we have a 22t and a minus 3t on the same side of the equal sign, so I can put those together. All right, now I'm going to move things over. Minus 8t plus 24 and plus 24. So it equals 0. 11t plus t squared plus 24. Let's write that in descending order, so we can see if we can factor. I'm going to put it on the left side because that's how I'm used to seeing it. And I like it that way. All right, so there is my trinomial. Do we know two numbers that add to give us an 11 and multiply to give us 24? Yes, 8 and 3. So I have t plus 8 times t plus 3 equals 0. What does that tell you? T can be a negative 8 or a negative 3. There's your answer. Now 20, although these sound confusing, if you can always think in terms of a whole, okay, they talk about hours in here. Pipe A fills a tank in 9 hours and B fills a tank in 6 hours. How long will it take both of them to fill the tank? So we're trying to complete the job, okay? So in 1 hour, how much of this gets done? 1/9. Okay, times however many hours, because we're looking for how long. So the variable is h here, hours. So 1/9 of a job times the hours plus 1/6 of the job times the hours equals the whole job. That's how those always get set up. So it's kind of similar, to be honest, even if the things change. So now, in order to add these, you need a common denominator. So we are going to multiply by 6, multiply by 6, multiply by... Oh, actually, we can do 18. Why am I doing that? Yeah, 18 is smaller. I mean, we could have done that, but let's keep it easy. What do you say? Okay, so 18, we'll do our common denominator. Times 2, times 2, times 3, times 3. So I have 2/18 h plus 3/18 h equals 1. That's 5/18 h equals 1. And then to get the h alone, I multiply by 18 over 5. Excuse me. And then 5 into 18 goes 3 times with 3 left over. So 3, and what would that be as a decimal? Who knows that? First spot is tenths, right? This is in fifths. So how many tenths would this be? Good. Either is fine. All right, so there you go, class. study for this one, okay? Make sure you study for this one. I am challenging you on this one. I'm purposely challenging both levels a little bit, okay? So I want to end with a little bit of a push. So do your best. Take care. God bless, guys. Bye.